You ever wonder what's really going on inside your body when you have an allergic reaction? You know, that sudden sneeze, the itchy eyes. It turns out it all starts with this one tiny microscopic decision. So today, we're going to go deep into the immune system to find the exact moment a totally normal cell decides to sound the alarm. So this really is the big question, right? What flips the switch on an allergic reaction? I mean, there's a literal biological switch that gets flipped, and it tells your body that something totally harmless, like pollen, is suddenly a massive threat. So, what is that switch? And who or what actually flips it?
Okay, to find that switch, first we have to meet the molecule that's, actually pulling the fire alarm. This is the chemical messenger that's just screaming attack.
And here it is, immunoglobulin E, or, just IgE for short. Now, it's a special kind of antibody, but it doesn't really fight off viruses or bacteria like you might think. Nope, its whole job is to trigger these huge inflammatory responses. And this system didn't evolve just to make us miserable every spring. It's thought that its original purpose was to fight off big stuff, like parasites. But sometimes it just gets its wires crossed and mistakes something totally harmless, like pollen, for a major threat. And that's why, for our story today, it is the main culprit.
All right, so if IgE is the alarm, then who's the one building the alarm system? Let's meet the hero of our story, or maybe the anti-hero. The factory that can be told to churn out this very specific, very potent antibody.
Say hello to the B cell. Think of these guys as the immune system's dedicated antibody factories. I mean, they're total specialists. They can produce this huge arsenal of different antibodies to keep us safe. So the real question is, what could possibly convince one of these expert factories to start making our allergy culprit IgE?
Okay, now this is where it gets really cool. A B cell doesn't just wake up one day and decide, you know what, I'm going to start pumping out IgE. Nope. It needs a very specific set of instructions, almost like a secret command from another key player in the immune system. So think of it like a secret handshake with multiple steps. First, an allergen, let's say a piece of pollen, has to literally bump into and bind to the B cell. That's step one. The B cell is now activated. But that's not enough. Next, a specialized T helper cell has to show up and deliver a very specific two-part command. The first part is physical contact, a direct interaction. The second part is chemical. The T cell releases these little messenger molecules called IL-4 and IL-13 that basically give the B cell its marching orders. So once that two-part command comes through, something pretty dramatic happens inside the B cell. It's almost like a factory manager gets a new, top priority order from the main office. And to fill it, they have to completely shut down and retool the entire assembly line for a brand new product. Now this is the really wild part. Look at what changes and what doesn't. The before and after antibody, they both still target the exact same thing, that piece of pollen. The part that grabs onto the allergen, it stays identical. But the other end of the antibody, the constant region, gets completely swapped out. The B cell literally stops making its standard issue antibody and starts producing the IgE version instead. And this whole process, this literal cutting and splicing of the cell's own DNA to change the product, it actually has a name. It's a super important mechanism in our immune system, and it's called class switch recombination. It's what allows our body to change the kind of attack it's mounting without ever losing sight of the original target. And in this case, well, it's switching to the allergy class. So here's the bottom line. After this switch happens, the B cell has a totally new identity. It's not a general-purpose antibody factory anymore. It is literally transformed into a specialized IgE-secreting plasma cell, and it has one single mission: to arm the body for an allergic response.
All right, so we've walked through the whole chain of events. So if you had to boil this entire thing down to just one single sentence, the thing you'd want to remember for the final exam, what would it be?
This is it, right here. This sentence is the whole story. B cells get that two-part signal we talked about, that physical handshake and the chemical messengers from helper T cells. That's the command. It triggers them to class switch and start churning out the IgE that drives allergies. That's the whole mechanism right there in a nutshell. And that, of course, leaves us with one last pretty big question. If we know the exact signals that flip this allergy switch to on, well, it really makes you wonder, doesn't it? Could we figure out a way to block those signals? Could we someday learn how to flip that switch right back to off?